This is the law of sines and cosines as part of Chapter 9. Please copy your cards. The law of sines and cosines. First of all, to begin, you use the law of sines or the law of cosines when the triangle is not a right triangle. So there's only one type of triangle you can use, what we've been doing in Chapter 9, and that's for right triangles. Well, let's say we have an obtuse or an acute triangle. Then we use the law of sine or we use the law of cosines to find a side length or angle measures. So again, law of sines or law of cosine we use when our triangle is not a 90-degree or right triangle, in other words. So here's the law of sines. Here's our triangle. That triangle ABC, which we have here, by any triangle with the lowercase sides, remember the lowercase letters represents the side lengths, and the uppercase represent the angle measures. Okay, so here it just says the lowercase represents the side lengths and the uppercase represents the angle measures. If this is true, and this is some type of triangle such that this is an acute triangle, C is not 90 degrees, neither is A or B. So this is an acute triangle with 3 acute angles. Then the law of sine says the sine A, these are proportional ratios. Sine A over A equals sine B over B, which is equal to sine C over C. So this is our proportional ratio. Now, when you're trying to find a side or an angle, if you're trying to find a side or an angle, you can compare 2 at a time. So you compare sine A over A equal to sine B over B, or you can compare sine B over B equal to sine C over C. And finally, you can also compare, even though they're not next to one another, sine A equal to sine A over A equal to sine C over C. So there's 3 options to choose from. And let's do that again. I compare sine A over A equal to sine B over B. And I'm using different colors. I can compare sine B over B to equal to sine C over C. Or I can compare sine A over A equal to sine C over C. There's a lot going on here. Okay, so just rewind if that went too fast. Okay, so you always try to compare 2 things at a time. I might compare these 2. I might compare these 2. Or I might compare sine A and sine C together with one another. Let's look at an example here. Let's say we're given this triangle here, triangle ABC, with this information. Suppose I have triangle ABC such that I'm given the side length of side C or side AB is 12, but I don't know lowercase b and I don't know lowercase a. And I need to find some angle measures and some sides. Let's say A is 45 degrees and C is 55 degrees. Okay? How do we find sine B? Even though this is apparently an acute triangle, or actually, yeah, let's go acute. Yeah, I'll leave it 45, 55. So the question is, what's the measure of angle B? The triangle sum theorem doesn't disappear. So to find the measure of angle B, I use the triangle sum theorem. Okay? So 45 degrees plus 55 degrees is going to be equal to 100 degrees. And I know 180 degrees minus the 180 tells me that that's the measure of angle B. Angle B is 80 degrees. So I can write that in here. Actually, I'll write it to the side. The measure of angle B is 80 degrees. Okay? That was easy breezy to find. I'm getting ready to erase this for some space, so hopefully you have that copied. Okay, so we just found the angle B to be 80 degrees, and I'm going to rewrite that in here, like so. Okay? Now, let's say we need B and A. First of all, we can never, even if A was given, and let's say A was, or B was given, and we said that was 13. We cannot use the Pythagorean theorem. We cannot use this, even if B was given a find, we cannot use this. This is no, that's only for right triangles. That's it. So we cannot use the Pythagorean theorem because we've discovered this is an acute triangle. So even if B and the side C or side AB was given, we can't use that to find side A because the Pythagorean theorem is only for right triangles. We can use the law of sines. So here's the law of sines. The law of sines, let's compare here, what can we use? And let me erase this 13 because that wasn't given to us. If I have, let's check and see what we have. Let's check. Sine A. Sine, do I have the measure of angle A? Yes, it's 45. That looks good. Do I have the length of side A? No. Doesn't work. Okay, let's see if we don't have it. Not that it doesn't work, we don't have it. Now let's compare that. We're going to compare sine A with sine B. Let's check B. Sine B, do I know the value of B? Or measure of angle B? Yes. Do I know side length B? No. So that tells me I cannot compare sine A to sine B. That doesn't work because I have two unknowns. I don't know the length of A and I don't know the length of B. So I erase this and I say that doesn't work. Too many unknowns. So I erase and I try it again. Let's see if we can try sine A compared to sine C. Let's try it again. Do I know the measure of angle A? I do. 45 degrees. Do I know the length of side A? No. And remember, I'm comparing sine A to sine C. They don't have to be next to one another. Let's go to sine C. Do I know the measure of angle C? Yes, it's 80 degrees. Bam, can use that. It's great. Do I know the length of side C? Oh yeah, it's 12. Okay, so how many unknowns do I have? 1. So I see the ratio that I need to compare. I'm going to compare the sine A over A equal to the sine C over C because I only have one on, that's A, side A. And I'm going to find the measure or the length of A. Now I just do substitution. Sine of A, what's the sine of A? Sine of 45 degrees. Divided by A, I don't know. I'm just going to leave that as A. Equals the sine of C. The sine of C is 55 degrees. Over the length of C. The length of C is right here, 12. I'm just substituting. Sine A, 45. Length of A, I don't know. Equals sine C. What's C? C is going to be 12, 55 degrees. And then over C, okay, this is the side of C here. Now you just use your calculator. You can cross multiply or do whatever it is you want to do here. Okay, and I happen to have my calculator up. I'm going to put this in my calculator. Sine, remember, sine 55 degrees is a real number. We just use our calculator to solve for it. So here I come in and put in the sine of 55 degrees equals some number. Equals that. Remember, we want all the digits. Okay, what was I dividing that by? I'm dividing that by 12. So that number here, so that 0.8191520443 is going to be divided by the 12. And it's going to give me a number. And this is the number I get here. 0.068 something, 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 something. Okay? So I'm going to extend this here. Rewrite this side here. Sine 45 degrees over A equals, we got 0.0, I'm going to check it again, 6826. 6826, some number. Okay? This is a basic algebra problem. I need A here. How do I solve for A? Well, that means I'm going to get A out of the denominator by multiplying both sides by A. And I'm left with, on the left side, the sine of 45 degrees, which is a real number. We need to put this in the calculator. Sine 45 equals 0.06826A. We're solving for A, so that means I need to get rid of this number here. So I'm going to divide 0.06826 on both sides of the equation. And before I go too far, let's find out what the value of sine of 45 degrees is, because remember, that's a real number. The sine of 45 degrees, and I get 0.707106. So this is going to be, I'm just substituting here, 0.707, what was it, 106? 106 divided by this number here, I'm just keep bringing it down, equals, that dropped out, equals A. So now I'm going to take this number and divide it by that in my calculator. This is my last number, divided by this 0.068262704 number. And I get 10.35 or 10 and 35 hundredths approximately. So that means when I divide these two numbers, that's going to tell me A. And again, I got 10.35, I believe it was, or 10 and 35 hundredths. And I'm going to round that up to a 6 or 36 hundredths. So 10 and 36 hundredths is approximately equal to the value of A. Yes, we had to do all that to find A. So now we know A. Okay? It's approximately 10 and 36 hundredths. Now we need B. Generally, what we've been using the Pythagorean theorem, C squared is equal to A squared plus B squared and so on. We can't use that because it's not a right triangle. Okay? We have to come in here. Now we can do the sine. We can compare here. And I'm going to copy this here. I'm going to bring that down here. Alright, where did it go? Here it is. Now let's compare. Now we've done this here. We need B. Okay? Let's go back to the tippy top. Which two do I compare? Do I compare sine A over A equal to sine B over B? Or am I going to compare, because I need B, sine B over B equal to sine C over C? It doesn't matter which one we do. We just need to compare, we need to be able to get this B. Well, let's start. Okay, I'm just going to try for giggles. I like to compare these two. All right, let's go to the tippy top. Sine B, do we know the measure of angle B? Let's go to the top. Yes, we know angle B. So we can come down here. We can check this off. Do we know the length of B? Side length B is no. That's what we're trying to find. So that's one unknown we don't have. Sine C, do we know the measure of angle C? Yeah, it's 55 degrees. So bam, we got that measure of angle C. And then finally, let's see, do we have the length of side C? Ooh, it's across from angle C, and there it is, 12. Yes, we have it. So there it is. How many unknowns do we have? Only one. So it looks like our comparison is going to be sine B over B, side length B over sine C over side length C. Now I'll just go and substitute. Sine of B. What's the sine of B? It's 80 degrees. So I'm coming down here. Sorry for the movement of the board, but I gotta keep going back up to show you. Sine of 80 degrees divided by B, we didn't know B, equals the sine of C. What's the measure of angle C? I believe it was 55 degrees. And it is. So the sine of 55 degrees over the length of C, and I believe the length of C is 12. Let's double check. Across from angle C is side C, and it is 12. So I'm going to put this 12 in here and go to work in my calculator. This time, let's do the sine of 80 and find out the real number and be done with it. So let's go here and put the sine of 80. Put in the sine of 80 degrees. And I get 0.98480 something. And remember, we don't want to round too soon. So 0.98, 0.98, is it 48? 480. 480 divided by, I'm just changing the sine of 80 into its real number in the calculator. B equals the sine of 55 degrees. Let's check the sine of 55 degrees. Sine of 55 degrees, which we've done before. Come on. All right, the sine of 55 degrees. Let me hit clear. Sine of 55 degrees is equal to this number here, 0.81915. Alright, so 0.81915 over or divided by 12. So now I can find out what this number, this 0.8195 divided by 12, I can see what that is in the calculator. Here it is, 0.81915, 20443 divided by that 12. And I get 0.68 something something something. Okay? So here we go. Just recopying this down. 0.98480 over B equals, when I divided these two together, we got 682, excuse me. Something something. Okay, 0.068. I think that was 2626. Alright, so we divided those two out and got this value. Now we need B. We need B all by itself. How do we get B? This is a basic algebra problem. We need B out of the denominator, so we're going to multiply both sides by B. We'll multiply and squeeze times B over there. That's multiplied by B. So let me rewrite this. 0.068266. Erase this. I'm just going to write it a little more clear. So here it is, 0.068266. Okay, and I multiplied B on both sides, so times B. Okay, what am I left with on the left side? This digit here, 0.98480 equals 0.682626B. I need B by itself, so I'm going to divide both sides by this number, 0.682626. Okay, divide that on both sides. And there's a 0 in front of here, so let me slide, there's a 0 here. There should be 0.0. Fix that up. 82626. That will cancel out, leaving us with B on the left. This number divided by that number there, and my calculator will be some real number. Okay? 0. What was that? The sine of 80 degrees. Okay, that's the sine of 80 degrees. I'm just taking the sine of 80 degrees. That's that number here. That 9.48 here being divided by number divided by this number here. Divided by 0.0682626704. And I try to take as many digits as possible. Equals, I get 14.43. That's 6 will make that go to 3. So 14.43 is approximately the value of B. And that's how we use the law of sines. 14.3. So this is approximately 14 and 43 hundredths, roughly 14 and 43 hundredths. And we'll do the law of cosines next.